Let's proceed now with essentially a start-to-finish example of level 2 processing. We're using a Veers tile that I downloaded and have been using in the previous examples or tutorials in this little series on level 2 processing. We've run the calibrate to generate a level 1B file. We downloaded the geolocation file so we can go straight to the level 2gen. Okay, we get the level 2gen user interface, which is, as we said before, is characterized by this series of tabs that each control or give access to a set of parameters. The main tab lists the parameter selections thus far. As I make changes, I can click apply and it will gather all the options that I've chosen and put them into this area and check them for any possible problems. It may highlight with warning the statements in this text that something's not quite right, that needs to be rectified. The fact that this text file is so short is because if it only reflects the options that are variations from the default. Okay, so let's proceed here by opening our level 1B file, and when we do that, it's going to associate with that a Geo File. It needs to find that. So if this is blank, then it's having trouble finding the Geo File, which should be in the same directory, same folder. And then it derives a name for an output file to be associated with the processing results. So it made some changes to our parameter file here, the I file, and so on. The next thing we need to do, regardless of the data we're working with, the OC is for Modus Ocean Color. We need to pick an appropriate processing suite for NPP. It would be for Veers, excuse me, it would be the NPP here, right? So that changed the assignment of the suite option. And then we need to get ancillary data for this particular date. So this file is from 2021, Julian date 054, and when I click that, it downloads from an archive associated ancillary data. If you don't do that, it's going to use some climatology and your results will not be as accurate. All right, and then we just proceed through these tabs, making choices that are reflected in the main area here. We click apply along the way if we wish, just to get it to sort of sanity check those options, because this main area will sort of embed a comment that gives you a warning if it sees something not quite right in your selections. Okay, in the products we choose what output variables, what new bands are we creating here. Okay, and there are all sorts of categories for these. For this example, I'm going to simply generate Rayleigh-corrected radiances here with the row S variable. If I turn that down, it shows the possible groups of those. If I turn that down, here I see all of the bands are generated and so on. Okay, I'll leave all of this checked as I want it to generate for all the bands in the file. Okay, so with that selected, the products get listed here as well. If you happen to become proficient enough to know, you can actually type in the text of variable names, but you better not misspell them or you'll get issues. And then click apply and go back to main, and you'll notice that the products have been updated to reflect your choices from this particular panel of the l2gen interface. Moving on to the next one. The processing options is the sort of mother load. It is where you choose all the options of the level 2 processing that you wish to enable and disable and so on. There's far too much here to go into much detail. There are parameters for aerosol correction. There are models that are used for various, processing that you choose. We're actually sort of disabling that. In this case, I'm going to disable a lot of things. Just, all we want is Rayleigh-corrected radiances. So we're going to sort of set aside some of what CDS can do for us. In this aerosol options, we can disable all of the aerosol subtraction, and we might be wanting to do our own atmospheric correction with the results, so we can disable atmospheric correction. We're just turning off a lot of stuff here. This will speed up processing. Now we come to the filter file. Okay, this is a small text file that contains some settings for filters applied. They're basically convolution filters that are applied during the processing. If we don't want any of that, the best thing to do is simply copy this file from where it's normally embedded in the installation of CDAS. Okay, there's sort of a canonical file there. Best thing to do is to copy that file. So I'm going to simply grab that folder. I'm copying that with a Command C. I'm going to go into the Finder and say go to a particular folder where I'll paste it there. Go, and I'll find that file. It's the list of files. It's MSL underscore filter. Okay, I'm going to copy. I'm going to come back to the folder that I was working in downloads, there, and I'll paste it. So there it is. I'm going to quickly just open that with a text editor. Let's see. There, whoa. And we look in it here. What we see is it's got a couple of stray light filters. The parameters here are documented, but we just want to disable that. So I'm going to put a hashtag in front of each of those to comment them out. I'll save that file. I'll quit this editor. And so now if I go to search for the file, I'll find it in my working directory, select that, okay? It's a little bit of a detour there, but it's, you can enable filters as you see fit, but it's best to have a specific filter file for the specific data that I'm processing. Again, we're sort of clearing out a lot of processing here. We're going to turn off the gas corrections, and then we're going to turn off a lot of the masking. Basically, we just want a row S for as many pixels as we can find, and we're just going to stop with that the set of parameters. We'll apply. We go back again, clicking this arrow because the main tab, or we can widen this window, it doesn't matter, or no, we can't. We'll go back to the main tab here. So all of these new processing options have been added to the options, the configuration for our processing here. Moving to the subsetting options, we're not going to do any subsetting. With VIIRS data, you just want it to process the whole original file and do your subsetting after reprojection later. Thresholds we don't concern ourselves with. Ancillary inputs have been filled in when we did a get ancillary. And the inherent optical properties options we're just going to leave alone. In miscellaneous, we're going to oversample this data at 250 meters. Just for a big output, as good as we can get. And then the calibration options we don't fool with. So those are all of the options. I click back here to the main, click apply, and scan it for any warnings or errors, messages or anything. It should be okay. Now I have the choice before I run this to save these parameters. And that might be a good plan, because maybe I decide, oh wait, I really did want to enable the gas options in processing. Well, I can load this parameter file, go make that change, and reprocess this particular data in with a new set of options that I didn't have to click through all of them. So we go to downloads, go to our viewers option. What I tend to do here is just sort of choose the source data file that includes its date and so on, and give it a .par for parameters extension. It's a text file. You can name it what you wish. It's just most meaningful that it reflect the data file that I'm actually working with, because it's very specific to that. So we can save that, and then we're ready to run. Okay, so we would click run. We get this confirmation of running. And if you get to the point where it says processing scan number 50, so it works in clumps of 50 raster scans, then you should be on your way. Under some circumstances, it may crash and give you a log file window instead. But if this runs to completion, or runs this far, then it should run to completion. Now, I'm not going to keep all of the processing in this video. I will edit out and maybe 8 to 10 minutes of processing on a laptop. And we will pick up where the results finally arrive.